In this video, we shall solve some word problems. And this is a word problem that can be modeled using a system of nonlinear equations. Exercise 1.24, Word Problems and Applications. Number 19. A planet's orbit is described by the equation 4x squared plus 5y squared is equal to 20. A comet's trajectory follows a parabolic path described by x minus 1 is equal to 4y squared. So where in the planet's orbit might the comet hit the planet? So find the coordinates of the intersection. So this problem is something like this. You have a planet and a planet follows an orbit. This one is an equation that describes an ellipse. So the orbit of our planet is elliptical. A comet crosses its orbit. The comet traces a trajectory that is described by a parabola. X minus 1 is equal to 4y squared. So the challenge here is to find that intersection. At these intersections, you will have a chance or a possibility that this comet might hit the planet. This one is a curve described by this equation, and this equation is an equation of an ellipse. And this one, the trajectory of the comet is described by your parabola. X minus 1 is equal to 4y squared. We must look for that intersection. You know what? Something like that happened in our planet. In fact, it's not just a comet. It was an asteroid. You're familiar with the history of our planet. Our planet had been the shooting range for asteroids in the past. There was not just one asteroid hitting our planet. There had been numerous asteroids that hit our planet. And one recent asteroid was an asteroid that killed the dinosaurs. This one impacted our planet some 65 million years ago. And you know what? Even though this impact decimated the dinosaurs, in a way, it brought good news to the Homo sapiens because the extinction of the dinosaurs allowed the mammals to flourish. During the days of the dinosaurs, the largest mammal was no bigger than a rat. And so had this not happened, had this asteroid impact had not happened, we will never see the rise of the Homo sapiens in natural history. There would not be Homo sapiens among the living things. So that asteroid impact killed the dinosaurs, and the crater made by this asteroid, well, actually you cannot visibly see it because it's been taken over by a body of water. But the site of the impact for this asteroid, some 65 million years ago, is somewhere now in the lands that are occupied by central Mexico. Okay, so the challenge for us is, suppose this is our planet, okay? And we will look for the points of intersection. So at those 2 points, this comet might just hit our planet. This is our system of nonlinear equations. We shall solve it by elimination. I will multiply the first equation by 4, the second equation by 5, and this produces this equivalent system. Okay, so what I will do now is I will add the terms, or I will add the similar terms, and look at that. So this one gets cancelled. So 16x squared, it has no similar terms in the second equation. So you just have to write it as 16x squared plus 5x is equal to 80 plus 5, which is 85. So this one is a quadratic equation. And that is what we want to happen. From a system of equations into unknowns, we want to produce one equation in one unknown. We can solve this by quadratic formula. I had been looking for the factoring of this quadratic equation, and I cannot find one. So let us do it by brute force. Let us solve it by quadratic formula. And so we have two values for x. X can be negative 2.41. Okay, so this radicand here is equal to 5465. And x sub 2, okay, I'm sorry, this one should be x sub 2. X sub 2 is equal to 2.15. We will pay attention only to x sub 1, 2.15. Because this result does not agree with the model of our curve. Because our parabola opens to the right. Our ellipse is centered at the origin. Okay, it's centered at the origin. And so, the only admissible values for x here, the values of x that we can admit here, would be the positive values of x, 2.15. Okay, so we will pay attention only to 2.15. We already have a value for x, and that is what we want to happen. Because if we have a value for x, we can now solve for the value of y. So let us solve for the value of y when x is equal to 2.15. Okay, let us use the second equation. So from x minus 4y squared is equal to 1, let us solve for y. Y is equal to plus or minus 1/2 times the square root of x minus 1. And so when x is 2.15, our value for y is going to be, okay, so plus or minus 1/2 times the square root of this. So it's going to be plus or minus 0.54. And you know what? This is another reason why we cannot admit the other value of x to our solution. Because the other value of x there, okay, let us go back. Let us go back to our slide. The other value of x is negative 2.47. So that's a negative. And you know what happens when we get the square root of a negative number? You look into your calculator and it returns an error message. So that one is another reason why we will focus only on the positive value of x. Okay, so x is 2.15 and y is going to be either 0.54 or negative 0.54. So we should be careful in writing the solution set. So the elements of your solution set come in pair. They come as coordinates of a point. So this is one point of intersection, x, y, and this one is another point of intersection, 2.15 and negative 0.54. Okay, so let us bring back again our curves. So this is our ellipse, the orbit of a planet, and this is the trajectory of a comet. And these two are the points of intersection. And the coordinates of those intersections are 2.15, 0.54, and 2.15 and negative 0.54. And so we got it right. We got it right.